Hi. Hello. Good afternoon, everyone. Welcome to Boiling the Frog, migrating to a modern message-based architecture without anyone noticing. I'm Hazel Bohon. I'm a senior software engineer at Particular Software, where we build in-service bus, which is a software library which helps you build distributed systems. I'm passionate about building systems. Sad that I had to look at my notes to remember that I am indeed passionate about building systems, but it is true. I'm also a .NET developer. I've worked in other environments, but I always come back to .NET. All the cool Lisp girlies always make fun of me for loving F#. Get a real functional programming language. I can't help it though. The heart wants what the heart wants. What this talk is and isn't about. So what are we going to be talking about today? I'm going to be very specifically discussing some techniques which are useful for performing migration from a monolith to a service-oriented architecture. So service-oriented architectures include microservices and other different versions of service orientation. Basically, the important thing here is moving into a system where you have separate services that are able to communicate in a distributed computing environment. And so that's what we're going to be talking about today. This allows you to move into a more modern application system where you have isolated services. Modern applications follow design patterns, which are generally understood by the industry to sort of represent best practices for producing applications that are reliable, reusable, extensible, and maintainable. Everyone wants that, right? Legacy applications, on the other hand, typically exhibit idiosyncratic behavior and often use out-of-date, no longer supported software packages. To steal from Tolstoy's novel Anna Karenina, all modern applications are like each legacy application is dysfunctional in its own way. The challenge of modernizing a legacy application can feel daunting. It can feel overwhelming. But it is possible to navigate these changes without burning out your whole team. Today I want to talk about the basic process for approaching this. People consider this, so please consider this as a framework, a series of guideposts for navigating through unknown territory. This is not a map. It's not a compass. This is not an algorithm. This is a set of loose heuristics that may help you on your journey to moving from legacy applications into modern environments. So the strategy which we use, which we found to be most effective for modernizing an application, has been to start by understanding the outcomes you want to achieve, deciding how to break the problem into smaller parts, successfully delivering those parts, and changing the organization to allow that kind of change, that kind of deployment process to occur repeatedly on an ongoing basis. In this presentation, we will discuss how to achieve each of these pillars. Fundamentally, change is hard. If a legacy application exists and is in production, by its very nature, we know that it must be fulfilling some sort of a business need within your organization. If it's doing so well enough, your business relies on it. While it may be a source of tremendous pain for your team, for the other software engineers that you work with, it is not necessarily the case that everyone in your organization feels the same way. I have worked on projects where many stakeholders would complain about the performance of the existing legacy application. But when we tried to introduce a replacement, we often ran into a lot of resistance. One of my first jobs that I had as a software engineer, everyone loved to complain about this green screen application that we had for the sales front end for people who were working at the front desk at this electric wholesale company that I worked for, right? Everyone loved to complain about it. And the order entry application, it was terrible, right? We attempted to introduce more modern graphic-based user interfaces. This was an exciting project for the engineers. Everyone loved it. They got to write new code instead of dealing with this ancient code base that no one really wanted to learn, right? And at first, the people at the front desk, they also seemed enthusiastic about it. Oh, cool, something new to work with, right? But they actually did, they enjoyed complaining about that outdated system. But what happened was, what we found was that as they were starting to move into that new system, they really didn't like it. They actually still preferred that old green screen situation that they had because they knew where everything was. They knew all the hotkeys. They knew how to use that tool. The tool had been working for them really well. And this is sort of a software development failure on our part because we didn't do a good enough job in understanding the actual use case of our users. So getting buy-in from stakeholders, not just getting buy-in from stakeholders, but also understanding their problems and their needs, understanding the business domain that you're working in is a big challenge. And it's something that you need to do in order to really build that trust with your user base in order to be able to actually successfully perform a migration like this. So software modernization, so we want to do that because it's easier to maintain code, right? We want to do it because it's easier to onboard new people. So at that same place, right, the green screen application, it was written in Alpha Basic, which is a language that at the time, I think maybe this was the only company left that was still using it. And it was a small regional wholesale electric supply company. It didn't exactly have a lot of people that it was hiring. There wasn't anyone who was learning Alpha Basic for the chance to get to work here, right? And so you would come on your first day as a new developer, and they would hand you this Xerox copy of a Xerox copy of a Xerox copy of the original Alpha Basic documentation, right? And that was pretty much all you got to onboard on this language. There was no tooling, right? There was basically nothing on Stack Overflow. You couldn't learn about this language in the way that we're used to learning about languages nowadays. So it provided a really rough onboarding experience for people. So this is something that you really benefit from when you move to more modern tooling, when you get away from your legacy application base. You get easier onboarding for your software engineers. So message-based architectures, why do we want message-based architectures? Well, it offers decoupling, scalability, and fault tolerance. Whenever you move into these systems, it becomes the case that if there's a failure in the middle of the processing, you still have the message queue information that you can fall back on for retries. You have easier scalability, right? You have higher levels of decoupling because now your separate units and modules are able to communicate to the message queue without necessarily having a concern for who their ultimate consumer is. This actually manages to deliver on that idea of fully decoupled software, at least in principle. So how does this work? So with asynchronous communication, apologies if you were at my earlier presentation today, because this is a bit of a rehash. So quickly, you have an orders service, right? And then that will communicate to the message broker. It just sends this order created event whenever an order is created. It's nice and simple. You're basically done at that point, right? Orders microservice or orders service has completed its task. It let the message broker know. So then the message broker, meanwhile, you can have a billing service, right? The billing service subscribes, says, I would like to know whenever order created events occur. And so the message broker goes ahead and can forward that order created on, right? Then we can bring in another one, an inventory service that can also subscribe and receive that same order created message. And so now what we've created is a system in which orders is able to do what orders needs to do. It's able to be responsible for its own domain. It's able to be responsible for that message. But it doesn't have to worry at all about these services that are consuming it. It's not even really aware of the existence of those services. And that allows for, as I said, greater decoupling, which really helps us when we're building out asynchronous systems. So asynchronous communication, you can use AWS, has SQS as a native option. Azure has Service Bus. And then Google Cloud has their pub sub service. So you can actually get cloud native message queues available to you if you're working in any of those, if you're working in any of the cloud environments. And definitely would recommend them. All of them do a pretty good job, do a great job of serving as a message queue. If you're self-hosted or prefer an open source solution, RabbitMQ is a great one that I often recommend to people. It has a lot of support within the open source community. It has a lot of updates. It's open source. You can self-host it. You can put it wherever you want to. It's reliable and does all the things that you sort of need out of it. If you're in a position where your organization really can't move to the cloud or can't really spin up an additional service like RabbitMQ, there's a lot of other options as well. Fundamentally, a message service a message bus isn't actually that complicated, right? What we're doing is we're just passing a message to some sort of an intermediary, and then it's forwarding it on to destinations. It's basically just acting as an exchange for things. Kafka, if you spin up an additional service, you can use Kafka, although it's not technically what it's meant for. You can use Kafka in this way as a message queue, But you can also use some more unorthodox things, right? We can use SQL. You can just write to a table and then read from that table. So the services are still able to act in an asynchronous way. They're able to be decoupled from each other. You're able to achieve all of this. That does run into scaling issues, but it's still something you can do as an intermediary step. You can use SMTP. You could just have it send emails to each other, right? That's one way that you can actually propagate your messages outwards. There's a number of different things, there's a number of different technologies laying around that can serve in this message queue capability if the specific needs of your organization or your migration require this. And then you can sort of graduate upwards into RabbitMQ or one of the cloud native options as you get into an area where you're able to do those things. So cross-service coordination. So when we're dealing with cross-service coordination, we have, so we have to worry about ACID transactions, right? Previously, we were able to do ACID transactions, which is where you have atomicity, consistency, isolation, and durability. But once we move into a situation where we're actually doing things across multiple services and coordinating that way, you lose that ability to have that same guarantee. And this is a challenge that we're going to have to work through when you're doing these things. One solution that's often put forward is the two-phase commit algorithm. The commits are broken into two phases. First is a voting phase, followed by a commit phase. The voting phase, a central coordinator contacts all of the workers and checks on whether each one of them is, whether or not they are able to make the state change. And then each of those workers responds and locks the row locally. Then you have a commit phase. If all the workers vote for the change, acknowledging that they're able to make the change, then we go ahead, then the coordinator instructs each of them to actually do the commit of the change. Otherwise, the rollback instruction is sent. This can be effective, but it does put a lot of potential burden for deadlocks on your system, right? Because at this point, you've now put locks on maybe several databases across several different services, all waiting to hear that acknowledgement or not hear the rollback, right? And so if you have, this can create these interesting distributed deadlocks that are much more difficult to resolve and can be really vexing when they occur in production environments. Generally, whenever we're working with distributed systems like this, we run up against what's called CAP theorem, which is that you can have consistency, availability, or partition tolerance. You can pick two of those. It's mathematically impossible. There's actually, we like to say theorem a lot, right? But there actually is a theorem that demonstrates this, that mathematically it is impossible, right? You can have consistency where you get the same answer across any of the nodes, or you can have availability where all requests get answered. You can have partition tolerance, which is where the ability to handle a communication failure between nodes. But at a certain point, you have to be willing to sacrifice one of these two things in order to have the other one. So for example, if you're willing to accept consistency, if you must have consistency across everything, right? Then you run into this challenge where you have to deal with what happens if you have partitioning that occurs. If you have a partitioning that occurs, how do you maintain availability at that point? You have to think through and accept these different limitations. So in general, for people moving from a system in which these state changes could be managed in a single transactional boundary, the shift to distributed systems can be sort of a shock. And often the reaction is to look at implementing these sorts of distributed transactions, things like that, to regain the guarantees of the ACID transactions. Gave us back when we had simpler architectures. Unfortunately, as we'll cover, unfortunately, this can lead to these distributed transactions, which really my number one advice on that is to just avoid them. In general, avoid distributed transactions as much as humanly possible. Instead, you want to use sagas. So sagas there's several different patterns for doing what's called sagas, where you're coordinating, orchestrating your different steps of a multi-step process across the different services. So if the order place service, so you can do this in one of two ways. One is that you can have sort of a set of continuations from one service to the next one. So the first service fires up a message. That message is then consumed by the second service, and then once it's completed its work, it makes the next step. And in this way, you can create a chain. which allows for coordination between the different services. The challenge there is that can be a little bit difficult to track that can be a little bit difficult to keep track of the workflow from a observability standpoint. Easy solution for that is you need to create some sort of a correlation ID that you pass forward through the different messages, and then you can pull that back out in the logs. The other option for using sagas is to have a coordinator that holds the state of the system. So each service, as it finishes its message, it will send out a message. That message can then go to the coordinator that can then update the state, and it can move from one step to the next. And it's pretty much all you want that coordinator to do, because you want to maximize its availability and you want to keep it as lightweight and svelte as possible. So these kind of give you much better options as far as ways that you might be able to handle these more complex workflows where you're communicating between your different messages. So all of that to say, there's a little bit going on there, but ultimately this is all manageable. So why do organizations resist these changes? Why do they resist going over to messages? Why do they resist moving to more modern systems? It's totally, people tend to be skeptical of the unknown, and rewriting the core business of an org can take a long time, right? Because you may have years and years of code base that you've built up there, and it will take, it's sort of the height of foolishness to assume that in a very short order of time, you could take something that maybe took 20 years to build and move all of that over into some new system, right? There's a commensurate amount of time that is required to do a migration. And that can really be a drain on organizations. It can be difficult for organizations to make that decision to affirmatively embrace, all right, we're going to stop everything. We're going to redo it all, right? And it's also the case that people have often been burnt by these sorts of rewrites before, right? As I said, when we had those, when we had the front-end application that we did where we tried to move from a green screen over to a GUI-based system, we kind of botched it, right? We didn't really serve what the customers actually needed. And I think that people who've been in software for a while probably all have similar stories where there was a failed upgrade or migration. And the customers, the consumers, they remember these things, and it erodes trust. So it can present a real challenge when trying to get buy-in from the stakeholders inside an organization for these sorts of things. Big problems. Big problems get big because systems amplify those problems and make them sticky. It's tempting to decide that a chronic problem is big enough that we ought to declare war on it, drop everything, hyperinvest, hold our breath, and do nothing until it is solved. But that's not really how the problem got here, and it might not be the best way for the problem to be solved. Or, to put it in more of a meme format, help me, I'm unhappy. All right, here's gradual positive change achieved through daily habits. No thanks, it's looking for dramatic escape. And there is a real correlation here. Moving a system over, migrating over into modern architecture is a slow process. It's something that you will have to break off piece at a time in a gradual way. And that is ultimately how it has to happen in order for it to be successful inside most organizations. And it's really how change happens in our personal lives generally too, right? We don't wake up one day and run a marathon. We wake up and we start building ourselves up towards that. We start training for it day after day, running. And the first couple of times you go running, you'll be really, really slow, right? Or you won't be able to run very far. But over time, by consistently practicing at it, you can build it up and you can move to the point where all of a sudden you're running 26 miles and you have no idea how that happened, right? This huge change in yourself. Okay, so migrating migrating the ball of mud. The rewrites can take on a life of their own. I had a friend who was working at an organization, at a newspaper. They started one rewrite, and then because the rewrite was happening, right, they started with a small rewrite. We're just going to rewrite this one module. We have the time, we have the resources, right? But then all of a sudden, management hears about the rewrite, and so more and more things get piled on until all of a sudden they're rewriting the entire system. Everything had to be pushed over, and it created this huge challenge for the development team because it was really all of a sudden a lot more than they could actually really handle all at once that they were being asked to do. Generally, when we're talking about trying to deal with these sorts of things, when we're trying to build these complex systems, we run into this what's referred to as wicked problems, right? In dilemmas in a general theory of planning, these were laid out as sort of these principles, things that make problems wicked as opposed to tame. So a wicked problem, to give a little bit of history here, in the first half of the 20th century, we had been defined by the success of the professional class. People had been experts had been able to solve problems that had never been solved before. The kinds of problems they were being tasked with, though, were things like, how do we build a road that's going to last longer? How do we make a car go faster, right? These are very tame problems. They're physics problems, essentially, right? It's just an engineering problem. It's simple. But then, in the middle of the 20th century, we started to see the professional class was being asked to take on problems that were of a different nature. And this was something that Riddle and Weber observed as we started having these problems where they were more social in nature. They coined the term wicked problems because this sort of problem isn't easy to solve because it's not just an engineering problem. It's not just make the car go faster. It's actually a complex social problem with humans involved in the system. And a system of humans is so much more complicated than you will ever imagine until you actually try to build something like this, right? And so, yeah, huge list of different things that all kind of contribute. And these are all things that very much appear within our lives as software engineers, right? We often run into the problems where solutions are not true or false, right? They're just good or bad. You can make a change in code, and it's not necessarily the case that that change is invalid, right? It's often the case that you're just trying to make it a little bit better, right? Wicked problems can always be described as symptoms of other problems, right? And one of my favorite ones here is, it cannot be studied through trial and error. That's a great one, but it's the, they do not have a definitive formulation, right? I really fond of that one because basically how we think about our problems, how we think about the challenges that we're facing when we're writing software can actually define what kind of solutions we're going to come up with. And so just the question itself, the way we think about the problem, has a tremendous influence on how we go about solving the problem. And so organizations which design, and so moving on, doing all the classics, here's Conway's law. Organizations which design systems in the broad sense used here are constrained to produce designs which are copies of the communication structures of these organizations. If the architecture of the system, there's another quote from Ruth Malin that I also really like. If the architecture of the system and the architecture of the organization are at odds, the architecture of the organization wins. The organizational divides are going to drive the true seams in the system. So in order to change our architecture, what we have to do is you have to change your organizational structure. For more on that specific thing, a really great deep dive on it, there's Team Topologies by Skelton and Pace. Really good book if you want to really dive into how to organize teams. Okay, so we've kind of gone through all of the basics of this. We've discussed the problems, the challenges, what message-based architecture is, but I really haven't gotten into it yet. How is it that we're going to actually go about migrating people over to this sort of a thing? So let's cook a frog. So step 0, before you start on any kind of a migration, consider these sort of like checklist of things that you want to do to get going on the system, right? You want to have trainings, brown bag lunches. You want to make sure everyone on your team has skilled up to the point where they are going to be able to deliver on this. So I have a friend who's working on a team of 8 people. 4 of them are the seniors, and they're moving over to Google Cloud provider, and they're using Kubernetes. And prior to starting on the project, nobody had any familiarity with any of that stuff. They were been all legacy application developers who've been working on this legacy application. And there wasn't really any institutional support within the organization for leveling up those skills, right? And so I got many a late night call from her asking about containers and how does this work, how does that work, right? One of the ways that you can alleviate that and prevent that pain for your team, right, is having brown bag lunches where you're skilling up everybody. One of the other things that you're going to want to be doing is, right, if you don't have them yet, you definitely need to add unit tests. You need to add code reviews. You need to modernize all of your process because you can't really make a modern application if you haven't modernized your software development practices, right? You want to be able to have CI/CD pipelines. You want to be able to do all of those things. So at this point in cooking the frog, we haven't even really turned it on the stove. This is sort of the mise en place level of getting ready. We're just putting all of our tools in place so that we're going to be able to do this. One of the things that I think is really essential is getting a hype man. You want someone who has the ear of the beneficiaries within your organization, somebody who is able to celebrate your successes. Because at first, we don't necessarily want to promote this too much, right? But we do want to eventually be able to do this. We want it to be the case that people hear about our successes, not hear about what we're going to do, but hear about what we've already done, because that will help build enthusiasm. And in order to do that, we need to have advocates within the organization, right? They can be people who are on your team, someone who's on your team who is outgoing in this regards, right? Or it can be someone who's not even on your team. Yeah, because often there can be people in the org who don't even know what the developers do, who don't know what you're doing, what you're building. And having a hype man is someone who can really help to build that support in the rest of the organization. Another role that I think is really helpful to find is finding a guide. So when you're making these sorts of transitions, sometimes it will be the case that you will not get all of the information, right? If you just get specifications from the management and the org chart and its traditional structure, you're going to miss out on requirements, things that people need, right? Thinking back to the people who are working at the front end, right? The cashiers. The only way that we could have actually known is if we had done the unthinkable and talked to those people in advance, right? And so this is where a guide comes in, finding someone in the organization who has a different perspective than you, who sits somewhere else in the org chart, right? Who has insights and knows things that you don't know. So I recently moved to Minnesota back in 2024. And prior to that, I had lived in the South, so I wasn't really familiar with snow at all. And I was very fortunate to make some friends in the area who were really helpful in educating me about all of the various things that you have to do in order to deal with snow. And I remember one morning, I woke up, it had snowed, I went out to go shovel all the snow, and my friend sends me a text message. They actually sent the text message a little bit before dawn, and it was been waiting for me there, and it said, watch out, this is what we call heart attack snow, because the fluffiness of the snow makes it the case, right, that when you're shoveling it, you can really overdo it and overextend yourself without even realizing you're doing it. And this was really awesome because it was topical, necessary advice that I was able to get because of this personal connection that I had built within the organization where I worked, right? And personal connections outside of the org chart, right, is a really great way to build this, right? Just water cooler chats, talking to people inside your organization who aren't on your development team. I know that can be scary for some software engineers, but trust me, it's not that bad, right? You can find affinity groups within your organization, right? People who have similar interests, right? Clubs, hobbies, things like that can be a great way to create these sort of unofficial touch points across the organization. And just remember, with trying to do these sorts of things, authenticity is key, right? We are talking about trying to build these personal connections. So finding ways that you can relate to other people inside the organization can really help and can be a great source of feedback and guidance. Keyboard shortcuts is a recurrent theme in this, but I had a similar experience where in another organization where I was working, our users found the keyboard-based navigation for the web app that we were building to be really, really painful. And this was something that the designers hadn't really thought about in too much detail, right? But it's something I was able to raise because I'd established a personal relationship with one of the users, right? We like to talk in our spare time, right? And in that way, I was able to pull this information in and bring that in as information that was helpful and relevant when we needed it when we were trying to build out the application. Okay, so we got everything ready now. We're going to move on to step 1. So this is where we're actually going to start publishing the events, right? So from prior, what we're going to do is we're going to start at the end. Whenever you are sending a message, whenever you're finishing a function, you're going to send a message. Where does the message go? It actually does not matter yet. We're not consuming the messages. We're just emitting events, right? Because as I was showing in the earlier thing, where the order service doesn't really care where it's going, right? It just needs to know that it needs to create order created. So that's what we're going to start doing at first. We're just going to start publishing the messages without really thinking about our eventual consumers. And like I said, you can start off with a SQL database if you're not ready to take that leap and jumping into RabbitMQ or something else. Really at this point, the water, it's a jacuzzi. We're not boiling yet. This doesn't take that much time, right? It doesn't add that much. And so then as you've started to add these in, this will sort of bleed into step 2, where we're going to start creating subscribers to those events from step 1. We want to do this in a very opportunistic way, right? Looking for situations where it would make sense to do this, right? And then we can trumpet those successes when we get them. So I had when I was working for the electric supply company, we had started doing this process, right? We had started whenever an order was submitted, we would admit an event, and then we didn't really know what we were going to do with them yet. But we had a request come in from one of the warehouse managers that people weren't noticing when the hotshot orders came in, right? The people in the warehouse. And so they had got this klaxon, and they'd got a little industrial controller, and they wanted us to put that in there and make it the case that the klaxon alarm would go brrr, super loud whenever one of these orders came in. And so we were able to build it and implement it much more quickly because we were already emitting that order submitted event. So all we had to do was just tie this into that. And so we didn't have to modify any of our existing code. We didn't have to add any additional hooks or do anything else. We were able to build this one-off success really quickly. And it made our development team really happy. We were able to get it done super quick. It made the managers quite happy because they got to hear their ridiculously loud alarm from their offices quite a distance away. I think the only people who were unhappy out of that were the people who actually worked in the warehouse who had to hear that sound going off. But that's sort of the first step, right? Now we've sort of brought it to a low boil. This is a thing where we're not dedicating a lot of resources to this, right? We're still not spending a lot of time. This doesn't feel like a rewrite yet, even, right? Because we're not really doing a rewrite. We're gradually migrating everything over. And so this means that, right, our various stakeholders, we're still delivering what they need. We're still giving them the features they want. We're still giving them the terrible ideas like this klaxon, right? Okay, so then step 3, after we've done this for a while, there's going to be these sort of cycles of destabilization and restabilization, because not everything's going to be like the klaxon where you're adding a new feature on. Sometimes you are going to be migrating more and more chunks. You're going to be starting to pull things out. And as you do that, you're going to be sort of destabilizing everything, right? So we want to pace ourselves with this. Really great quote from off-roading: as slow as possible, as fast as necessary. So we don't want to move with this any faster than we have to, right? So be prepared to sort of redraw these service boundaries. As we're starting to divide and shape things out into these separate services, one of the things that is going to be a challenge, right, is that we might get it wrong. One of the biggest challenges in being a software engineer, I think, isn't so much the code. Most of the time, it's not the code. It's not the technical stuff, right? It's actually understanding that business domain that we're working inside of. It's understanding what it is that we're doing, right? I've worked at a lot of different places, and when I first started working as a software engineer, I very much felt that it was the case that, yeah, whatever, I just learned the code, I can go wherever, I can work wherever, I can do the code anywhere. But there is a real cost when you move to a new organization or you move to a new business. All of a sudden, you have to learn how that business domain itself works, because you can't really be fully effective as a software engineer if you don't understand those things, right? So yeah, we want to be prepared to redraw those service boundaries. It's a situation where we're going to have to be thinking through it over and over again, and we're probably going to get it wrong the first couple of times, which is why we don't want to go any faster than we have to at this point. One of the things that you can do when you're doing these migrations, strangler fig is a great pattern for this. It helps to sort of keep everything, it helps to keep the chaos of this reorganization separated out, right? So here you have strangler fig pattern, right? Client app is talking to the legacy system. Then you add a facade in between. This facade allows you to now start moving things over. So you can start moving things over into the new system as those services come online, until eventually you're able to replace the whole thing and just have the facade and the new system. You no longer have the legacy system, and then you can get rid of the facade too and just have the new system. So let's talk a little bit more about what those services are that we're building here, right? So it's a technical authority for a given business capability, right? All data and rules should reside within that service. The service boundaries, the scope and limit of a service separating the functionality and data contained within the service from that which is external to it. So each service will contain its own independent data and functionality. So for those of y'all who have CS degrees, right, you all remember encapsulation, right? That's all this is, right? Services are just encapsulation from the way we would build modules, right? From the way you build object-oriented programming. It's just that applied outwards a little bit more, right? Applied at a slightly higher level. So here's sort of an example, right? Where we have a client UI that speaks over to the sales endpoint. The sales endpoint emits the order placed, right? Which then can go to these multiple endpoints. Those endpoints are then able to communicate back, right? And then that's all able to be coordinated and orchestrated across our message broker. So now we've managed to kind of move in this direction, right? So now, after we've done all of this, we can move on to step 4, our final step. So for this one, what we're going to be doing is we've properly isolated our services. We have governance over the data. So properly isolated services have governance over their own data. Once you've understood the partitioning, you've understood your service boundaries, you have to take on this big challenge, and we kind of leave it for last. You need to actually break up the database. And for a legacy application, that can be a terrifying undertaking, right? It's been my experience, right, that legacy applications, the database is the thing that grows the woolliest and the strangest over time. I worked at a place where we would have 1,000-line long stored procedures, just true monsters. The business logic itself lived in the stored procedure. I see some people nodding. Maybe we're former coworkers. And so in order to migrate away from that, it becomes a real big challenge. That's why we kind of leave it to last, because hopefully at this point, if our hype man has been working correctly, if we've been delivering successfully, we do have some level of institutional support, right? The managers have seen that, hey, whatever it is that they're doing, this is working. And that's when we're going to try and hit them with this thing that's really hard. This is going to take time. This is going to possibly impose limitations on development, on new feature delivery for some time period while we're going through this. But once you've understood how to partition everything, you can think effectively about how to split up the data. And then moving things into separate tables, you can start by moving things into separate tables, creating the isolation. You can move it into separate schemas within your database, right? You can do those steps. And that can actually be a successful and complete technique, assuming that you have sufficient discipline within your organization for that, assuming you're not really moving into a fully independently deployable microservice situation. That can be a totally sufficient solution. It can be put off to last because it's sort of the most tricky and time-consuming, but it also has some really good opportunities, right? Some of the services, SQL might not make sense, right? You might want some of the services to be using Elasticsearch, or you might want them to be using NoSQL document stores, right? Different solutions can make sense in different ways. And so there's also a really great opportunity to deliver additional value to your organization when you're doing these sorts of migrations. So sort of wrapping up, I feel like some part of your legacy system is always going to sort of stick around. It's always going to survive. I like this picture to represent that because butterflies evolved in order to consume, in order to be pollinators, right? So they evolved to deal with flowering plants. But the alligator that they're sitting on here is older and has existed on this planet longer than flowers, longer than angiosperms. And yet they still exist together. For all the butterflies we may create, there's still always going to be like an alligator somewhere lurking around, right? My friend who works for the newspaper, she was telling me about how, yeah, we did this big giant migration. We moved everything over, all the stuff, all of it at once. And then she went, well, actually, our newsletter is still on the old system. So very often, migration off of legacy systems feels like an incomplete and unending Sisyphean job. So don't feel too bad if you don't have it completely finished in your migrations. Wrapping up, change is hard. Change is never over. And no frogs were harmed in the making of this presentation. Thank you. I think we still have a few minutes for questions. If not, you can always hop onto the Discord, and I'll be answering questions later. Oh, hi.
Hi. So you were talking about cap theorem earlier and how you've got this decision to make. which decisions have you made and why between the three?
So when dealing with CAP theorem in general, I've gone for an eventual consistency has been the thing that we've emphasized, right? And so being able to reply to the messages as much as possible and having that partition tolerance has been the thing that we've emphasized. I think that it depends, right? It always depends. One of the reasons that you would want to go and emphasize consistency, right, is if you're building like an accounting system, right, or something like that where you need this authoritative source of truth. In those situations, you would rather not give an answer than possibly give inconsistent answers. And so that's kind of where that trade-off usually comes in, right? I think a lot of people have gotten used to the idea of eventual consistency and have gotten used to the idea that numbers and information can be a little bit inconsistent over time from the computer systems, which is a weird compromise that we've all gotten very comfortable with. Oh, hi, you there.
So when you were on that topic and you were mentioning acid transactions, it sounded like you were heading straight towards basically available soft state eventual consistency, the base transaction. Like, you ever heard that mnemonic?
I have not heard that recently. I'm going to have to I'll look that up, and I may add that in. Thank you.
Yeah, it's a, keep in mind you got an acid transaction and then the opposite is the base transaction. It's just a...
That's absurdly cute that they came up with that. That's like such a good pun. Wait, is that a real thing, or are you making this up?
It is a real thing.
Okay. That's so perfect. Were there any others? Okay, I think we can go ahead and call it. And like I said, I'll be answering questions in Discord later.